To the second part of our lesson. Last time we were looking at innate immunity, and before we go on with acquired immunity, let's look at the details of phagocytosis and inflammation, which we saw are part of innate immunity. This diagram shows phagocytosis. It shows phagocytosis. In fact, this is a eukaryotic cell, a phagocyte, can be compared to an amoeba, which you saw very well, that feed by an engulfing small particle. And this small particle could be a bacteria, a prokaryote. These are pseudopodia, which look like roots on the surface of the cell. But pseudopodia can also be developed. These small protrusions which developed are also part of pseudopodia which can be developed. So the microbe is attracted to the surface of the bigger cell, the eukaryote or the phagocyte. Then it attaches on the surface of the phagocyte. There are receptors in the surface on which it attaches to. Once it attaches to it, is enclosed by the cell membrane of the phagocyte. Then it finally engulfs, and the membrane forms around it. That membrane derived from cell membrane is called phagosome or phagocytic vesicle. In the feeding of amoeba, we call it a food vacuole. Here it is called a phagosome. Inside the cells, we have lysosomes. In white blood cells or immune cells, we see them, we call them granules. But they are in fact lysosomes. They carry normally enzymes or biologically active substances which are involved in killing small organisms like bacteria. Those are the prokaryotes. So the lysosome will fuse with phagosome. The cell membrane of the lysosome fuses with the cell membrane of the phagosome to form what we call the phagolysosome. At that time, the enzymes in the lysosome or the biologically active substances, as we continue studying, we'll know the biologically active substances in the lysosome or granules. So they digest or destroy the foreign material or bacteria. When they are digested, then if they are of value to the white blood cell, they will be taken in. They will diffuse in the cell after digestion to be used. But if they are not useful, then they are retained here and still passed out. But if they are useful, the useful ones are absorbed into the body cells, and then unuseful ones and indigestible materials remain, and they form what we call residual body, which is also a small body like the phagosome, which then carry these materials away by reverse engulfing, and then they pour them away, which means the cell membrane opens and they are released out. The particles released now are not infectious in any way to other body cells. So that is how phagocytosis occurs. That's how phagocytosis occurs. The content of lysosome or granules we'll see much as we talk about them, like the reactive oxygen, and also on and so forth. So we'll move now to inflammation and see what inflammation is in details. Inflammation results when the body tissue is injured. The injury can be by a cut, hit by a blunt object, or by toxin, those are poisons, heat, being burnt, or by infectious substance, like when they infect like bacteria. When damage occurs, the nervous cell releases chemicals known as vasoactive amines. These are mediators of inflammation. So they include histamine, bradykinin, prostaglandin, and many other like C-reactive proteins. So this chemical, when released, causes changes in the blood vascular system, mainly at the point where there is an attack, where there is a wound or injury. So they cause vasodilation of the vessels. The blood vessels around this plate increase in diameter. You know what that effect causes? That a lot of blood moves to that area. There is also increased permeability of their walls, especially the capillary. They leak. So there's a lot of liquid leave the blood vessels more than it does in normal circumstances. Then there's what we call cellular infiltration. The immune cells move to this particular area. They are attracted by some of the substances which are produced, which are said to be chemotoxic. They are chemotoxic, which means they cause chemotaxis. Chemotaxis is a movement of cells in a particular direction. So they cause these immune cells to move into this particular region. So vasodilation, as I say, causes increased blood supply to the affected area. And because of that, so many red blood cells come there, causing it to the place to be red. The activity creates a lot of heat, so the place also become hot. There is increased also supply of molecules and immune cells, as I said, also yes, there molecules which will help in destroying the infecting or foreign substance. The leaking fluid will also cause swelling in the area because more fluid moves out into the tissues than it is taken back to the capillary. This occurs at the capillary bed. So there's edema, swelling of the body tissues. Edema is seen in pregnant women. Sometimes the blood does not move back to the body as it goes to the extremes of the leg. So the leg swells and what is called edema. This also increases tension and causes pain around the place where there is inflammation. Then I've said other chemicals that are released in this place are the ones like acute phase proteins, like C-reactive proteins. This one we saw earlier, they activate complement system, and that means inflammation is enhanced, and this also kills the infecting microorganism by lysis, which is bacteria. We talked about chemotactic factors produced at the site of injury, attracts phagocytes and other immune cells to that place. Then there's also production of a lot of reactive oxygen and nitric oxide. This one also kill microorganism. This also kill microorganism. So inflammation normally will continue until what what was causing inflammation, is cleared. But if it is an agent like sand, which cannot be cleared, then the destruction turns to the tissue of the body. The tissue of the body can be destructed. So things like silicon, if they get into the body, they will trigger inflammation. But since they are not destroyed, it's the body tissues that end up being destroyed. But those ones we can see later. Then you can look at the mediators of inflammation now one by one. You see the histamine, kinins, acute phase proteins, defensins. So histamines and kinins caused by dilation and increased permeability. Bradykinin stimulate pain receptors. So it makes you feel pain, and that is a way of protecting yourself from injury. Because once you feel pain, you do not continue to do whatever brought the pain in you. So then we have acute phase protein like C-reactive protein, enhance inflammation and cause killing of the infected substance by activating complement system. Then we have defensin, which kill bacteria by lysis. Then once we have looked at inflammation, then we can now look at the difference between innate immunity and adaptive immunity. But I think we can leave this and look at it later after looking at adaptive immunity. Let's go and look at adaptive immunity. You can come to the table later. That will make it much more clearer. So let's look at adaptive or acquired immunity. Adaptive or acquired immunity, we said, is specific reaction to foreign substances. Foreign substances are also called non-self. I'll take a bit of time to explain a few things. Immunology has its own terminologies, and therefore it has its own vocabulary. So as we learn, I would wish that if you get a new word and it is explained, you can put it down somewhere and keep on referring to it. Like this word non-self is not just a normal English language, but in immunology, the self refers to what belongs to the body, the host body. So it is a number of things, the organs, tissues, cells, part of those tissues, or what your body cells produce normally. The immune system of the body is able to organize these things, and they know they cannot react against them. So they are called self. The foreign substances are called non-self, and the body will therefore react against them. So adaptive immunity knows what belongs to its host body, and therefore they are called self, and what is foreign, that is called non-self. So the body will react specifically to these foreign agents, which are referred to as non-self agents. We said they could be living microorganisms or substances or chemicals. So that one is to remember what self and non-self is. So the body immune product reacts specifically. So we said if an non-self is a bacteria A, it gets in the body. The body produces chemicals specific to that bacteria A. Those chemicals, such chemicals could be antibodies, So we'll talk about antibody, but remember, antibody is removed by immune system against non-self. So this specific antibody will only act on bacteria A. So the body reacts to the organisms that induces the response. That's what I've just explained. This is the second phase of defense, the second line of defense. We saw the first line. So characteristics of adaptive immunity is not present at birth. It starts after birth when you are exposed to non-self agents. Now I'm not going to use the word foreign. From now I'm going to use non-self agents. Then it is specific to non-self agent. If it is bacteria A, it will only act against bacteria A and not another thing. It has immunological memory, which means during the time it is reacting against non-self, it is also producing some immune cells known as memory cells that remembers that non-self. In the next attack, the attack is more vigorous, stronger, and larger in volume. So remember that. Regulation, always there's increased response with increased stimulation. When the stimulation goes down, the response is removed or also goes down. Self-tolerance is, I talked of non-self and self. So the immune system knows the self and therefore it cannot act against the self. The immune system cannot act against the own body system that hosts it. That's what we call self-tolerance. So the immune response increases with continuous exposure. That when you expose, the more the exposure, the more the reaction. So let's look at types of acquired immunity. Let us look at types of acquired immunity. Types of acquired immunity is divided into passive and active. So let's start by looking at passive immunity. Passive immunity is achieved by transfer. Is achieved by transferring something to another place. So, which means that other person is not actively involved in producing its own. So it only receives. So it is being transferred. So it involves transfer of antibodies or sensitized cells from a person who is immune to a person who is non-immune. Remember individual immunity. There are some people who are immune because immunity differs and others will be non-immune. So this is a case where the immune person is used to make the non-immune person immune. You are susceptible to diseases, but you can be made unsusceptible to diseases by transferring the immune substances from the person who is not susceptible to you. That's what we are talking about here. So there are two things that can be transferred. One of them is antibodies. We said the body produces antibodies against non-self agent. So this person who is immune is able to produce antibody. So those antibody can be transferred to the person not immune. When they are transferred, then this person become immune also, so it can defend itself against this particular disease. But since it's just given, like food, when you are given, once you eat it, it disappears. So the passive immunity is short-lived. Another thing that can be passed over is sensitized cells. Immune cells or red blood cells exposed to antigen become active and can sense non-self and act against them. So We can also take such active cells, sensitized immune cell from an immune person to an immune person to assist them become immune. So those are the two ways in which we can give an immune person immunity by transformed antibody or sensitized cells. So we have two types of acquired passive immunity. So we have natural. Natural means it occurs naturally. So there are two examples, but it's about the mother and the fetus. The mother can pass immunity or antibodies through the placenta to the fetus. It can also transfer antibodies from the milk to the born baby and the baby is sucking. So those are the two ways in which you have natural passive acquired immunity. Artificial passive acquired immunity can be through vaccination or treatment. So there are some things that are treated with antibodies. So like tetanus or snake bite. So you get antibodies against the toxin of tetanus or snake. So that way you have transferred immunity from one individual to another one by artificial means. So you make the antitoxins or antibodies, then transfer them to a person who cannot produce the same. Normally, just in short, when you want to make antibodies against tetanus toxin, you take the tetanus toxin and inject it into an animal like a horse, which may not be killed by the tetanus. If it is not killed, then it produces antibodies against the toxin. Then you isolate the antibodies and use them. You put snake's poison into animal the snake cannot kill. This poison cannot kill it, produce antibodies which you use again to transfer. Then we have acquired active immunity. Yes, acquired active immunity. So this occurs when now, instead of giving out the antibody or sensitized cells, you actually make the body to produce its own antibodies or sensitized cells. The first passive case was equivalent to somebody who does not have food and you take the food to that person. They eat it and they finish and you provide again. But here is a case where somebody does not have food, but you give them the land and the farm implements to use and start producing their own food. So this one is long lasting because this person knows how to produce and continue producing. So here is a case where the foreign body is put, non-self is put in the body and the body produces antibodies or sensor cell against that, and that body now become immune. So we have two types, natural active acquired immunity. This occurs due to natural infection. The body is naturally challenged by foreign body antigen, non-cell, and then it produces antibodies or sensitized cells. These are what we call lymphocytes. Immune cells are called lymphocytes. You'll see that one later. Then artificial active acquired immunity is vaccination. So here again, instead of producing the antibodies sensor cell direct, we get weakened antigens which are prepared, weakened. We can weaken them by boiling or reacting with some chemical. Then we inject them into the body. Because now they are weak, they cannot kill, but they can sensitize the body to produce antibodies and sensitize immune cells, which then protect the bodies. So those are the two types of acquired immunity. Then we have mediators of active immunity. This one sometimes are referred to as another way of classifying active immunity. So active immunity can be classified into two, depending on what mediates them. So we have humoral and cell-mediated immunity. Humoral, we had talked about it, and we saw that it is caused by substances produced by immune cells. So this is mediated, this is the type of active immunity mediated by molecules in the blood and mucosal secretion called antibodies, but they're not only antibodies. We saw that even complement system are all here. So they are produced and they're the ones, that's how we differentiate this with this. So this one are substances produced by immune cell, and cell-mediated immunity is immunity carried out by the immune cells themselves, So here is mediated both by T helper cells and T cytotoxic cells or cytotoxic T cells. T helper cells produces cytokines. We learn about cytokines. They are a group of compounds which help in regulating immunity. So when T helper cells produce cytokines, they can activate phagocytes, they can activate B cells to form plasma cells and produce antibodies. But C cytotoxic cells, we said they kill other cells by cytotoxic effect. Remember that. We talked about cytotoxic effect. So this one kills cells by releasing proteins, cytokines, or enzymes that kill other cells. That's why we call them cytotoxic T cells. So then we go down to antigen recognition. This again, I can even refer to it as antigen processing. We look at antigen and we see that some antigens are big, like all bacteria is so big. So the immune system cannot be recognizing the old bacteria. So the immune system will recognize a small part of bacteria or antigen. That is called an epitope. We learned that. So to get an epitope to be exposed for recognition by immune cells, the bacteria must be broken down into smaller molecules. Then the smaller molecule are then recognized. So this is the process of antigen processing. So the phagocytes, like macrophages and many other cells, are involved in antigen processing. They engulf, like we have seen phagocytosis, the antigens, and break them down in small pieces. During that process, there's another group of molecules known as major histocompatibility complex. So major histocompatibility complex are classes of membrane-bound glycoproteins. They are membrane-bound glycoproteins. There are two, class 1 and class 2, major histocompatibility molecules. So these molecules, in simple terms, act like a hand on the surface of antigen-presenting cells to show the foreign or epitope or non-self to immune cells. So if they are not presented in this MHC, the immune cells will not see the antigen. The antigen must be presented as a complex that they react with class 1 MHC or class 2 MHC. for a start, you can just remember the 3 words MSc. It is allowed. You can write that even in exams. Nobody will deny you the marks. Class 1 and class 2 MSc. So the antigen, once processed, must be carried in this molecule for immune cells to see them. So class 2 molecule present antigen to T helper cells, while class 1 molecule present antigens to T cytotoxic cells. So remember, class 2 molecule present antigens to T helper cells. We learn about T cells, but as I've said, make an effort to know these things as we mention them. Class 1 molecule do the same to cytotoxic T cells. So that is what we call antigen recognition. Antigen will never be recognized until it is broken down and carried by class 1 MSc or class 2 MSc. Don't forget that. Then let's look at stages of acquired immunity. Stages of acquired immunity, the first stage is cognition. The non-self or foreign particle must be recognized by the immune cells or lymphocytes. We look at these cells. This term lymphocyte will be very common. You understand it. So we have seen that the antigens must be broken down to small pieces to expose the epitope. Then the epitope must be carried in MSc molecule. That is when the immune cells will see them. Then the second stage is specificity. The reaction to this antigen is specific. So the antigen that activates an immune cell will be destroyed by such immune cell and not other immune cells, or such immune cell will not destroy any other antigen. So if they produce antibodies or sensor cells, they will not react against that antigen which has activated them. So then activation stage. During activation stage, there is also mass production of the same kind of activated or sensitized immune cells. This is to amplify the effect or the reaction against the antigen, so that if antigens are produced, a lot of antigen will produce, so that if antibodies are produced, a lot of antibodies will produce against antigen. But some of these cells become memory cells. You remember what we talked about memory cells, so that in second attack they are ready, and the effector stage or the action against antigen is much faster, as we had said. Then the last bit is effector stage. Remember, in physiology, anatomy and physiology, receptor and effector. So receptor normally receive information, pass them to coordinators, and effectors carry out the action. The effector is like the muscles of the arms which carry out the action. So once activated, those cells become effector cells. Once activated, they produce effector molecules like antibodies. So these effector cells and effector molecules are the one which destroy the what? The foreign substances or non-self. So that one should remember. Then lastly, I'll define some two terms that as immunologists we should just know. There's local immunity. Local means particular area. So local immunity is the immunity at the site of infection. If it is the nose, where there is an infection, then immunity at the nose, that particular area of infection is called local immunity. So this one mainly is in the body, and mainly sometimes in the body surface. We look at types of antibodies. Now what is called secretory IgA, just don't mind about it, but that's what we mean local immunity. Herd immunity refers to overall level of immunity in a community. So when we have many people who are immune or who are resistant to a particular disease, then we have good herd immunity. But if we have few people who are resistant to a disease, then we have low herd immunity. When the herd immunity is low, then the disease is spread much in the community than when it is high, because many people are susceptible and carry them on to other people. That is why during COVID-19, like now, the government is trying to beef up the herd immunity by giving the vaccine. When many people would have had the vaccine, very many people would be resistant to COVID-19. So transmission rate would be low. But as per now, very many people are vulnerable, so they get it and transmit it so fast. Then finally, we have a flow diagram, which in some cases is brought early, but I think at this level, it becomes much clearer than when you started with it. So types of immunity, using a flow diagram, we have immunity. So we have two broad ones, innate and acquired. Innate, we saw first line in innate is an anatomical barrier. Then these other ones are waiting inside should the foreign body on and self go through the skin or mucous membrane, because this is mucous membrane and skin. So then we have phagocytic cells, blood proteins, these are basic proteins, C-reactive proteins, complement systems, then we have cytokines. Then we come to acquired immunity, we have passive, active, then we have natural acquired, passive, artificial acquired, passive, we have natural acquired, active, artificial acquired, active. But under active, remember also we have humoral and cell mediated, which you should know is under active. Thank you, and let's meet next time.